Hey guys, I'm going over the FRQ over research methods that we had at the beginning of the semester. So first, I'm going to read you the prompt, and then I'm going to read you the questions, and then I'll go over like each question about how you should have answered it, what a majority of people did, that either was wrong or was right, and then the grading scale at the very end. The prompt was, a researcher designs an experiment to study the effect of an audience on individual college students during the performance of a difficult manual dexterity task. He will assign 20 students to each of two conditions. In one, the students will use a pair of tweezers to place small cubes of wood into a box, which has one tiny opening at the top, while being observed by an audience of 30 peers. In the second condition, a different set of volunteers will perform the task with no audience present. All participants will have 30 seconds to place as many cubes of wood into the box as possible. The researcher hypothesizes that the group that performs the task with no audience present will outperform the group that works in front of an audience. So there are A, B, C, D, like all the way to H things that you need to respond to. It's best just so you don't talk in circles, and that way it's easier for a grader to read, that you do answer this in bullet point form, just like it's given to you, and you answer it in the order that it's given to you. So don't go from like answering D to A all the way to H back to B. So just go A, B, C, D all the way down. So here's what you had to answer. On A, discuss an issue of operational definitions in this study. B, discuss appropriate procedures for choosing and assigning participants. C, identify the experimental group. D, identify the control group. E, identify the independent variable. F, identify the dependent variable. G, discuss appropriate controls for any one possible confounding variable. And H, discuss appropriate controls for possible experimenter bias. So I don't know if you've noticed, if you looked at your FRQ and how I've graded it, I ignored everyone's letter A. I didn't even grade it because I think the majority of people read this question wrong. Like they didn't understand what the question was asking. So I just didn't even read it. But the question is, discuss an issue of operational definitions. It is not saying discuss a problem with how they use operational definitions, like discuss how they issued operational, like how did they use, what did they, issuing is like, how did they use, what did they basically operationally define? So there's not too many things that you could have written here as a correct answer. I didn't read anyone's. I mean, I read probably the first class periods that I graded of A's, and I realized that they were all wrong. So I just didn't even grade it. But you should have said something to the effect of the difficulty or the manual dexterity task was defined as like how many small cubes of wood they place into a box. Or you could have said they defined an audience of 30 peers, or they defined their performance with how many cubes they can do in 30 seconds. So it's asking like, just give me an example of something that they operationally defined and how did they define it. So that's basically what the letter A is saying. It's not asking for a problem. It's asking for how did they use operational definitions. Most people could tell me about B. Most people understood the appropriate procedure for choosing and assigning participants. The majority of people did get this right. I accepted 2 right answers. Either you say something about like random selection and random assignment, but you couldn't just say random selection or random assignment. You have to say what that means. Like a lot of people that got the point, they say random assignment, random selection, which means everyone has the same probability to be chosen. Everyone has the same opportunity to be selected, to be part of the experiment. Or if you just gave an example of how you would do that, like put everyone in the population's names in a hat and randomly draw names out of a hat. A lot of people talked about ID numbers or some computer-generated programs. So you were just giving an example of random selection and random assignment, or you could have said random selection and random assignment with the definition of those things. You cannot have just said random selection and random assignment. That does not mean that you know how the appropriate, like what is the procedure of random selection and random assignment. Most people got C, D, E, and F correct. This was the experimental group, control group, independent variable, and dependent variable. So the experimental group is the people that you are testing. It's a set of people. So the experimental group are the people in front of the audience. You're seeing if the audience is going to have any effect on their performance. So the people that have the audience, not the audience themselves, the people performing their task in front of one, that is the experimental group. You're going to compare those results to the people that had no audience. So that's the control group. Control is whoever you're comparing the experimental group against. So the experimental group are people in front of an audience, the control group that has no audience. The independent variable and the dependent variable, how they're related, is the independent variable is going to affect the dependent variable. So what is going to affect what? And it's the presence of the audience is going to affect how many cubes people can put in the box. So the independent variable is the presence of the audience, or you could just say the audience. A lot of people said the 30 peers. That's what they defined audience as 30 peers. So that one was fine too. And then the dependent variable is, you could have said their performance on the task. Of course, I think the AP test would probably want, like, how did they define performance? Oh, the number of cubes they could place in a box with tweezers, that's the dependent variable. So the dependent variable, the number of cubes they can put in, is dependent on whether an audience is watching them or not. So that's why the independent variable is the audience or not, and then the dependent variable is how many cubes they could put in. So on G and H, a lot of people got this wrong. Not too many people. I think there was just maybe 2 or 3 100s where everyone got everything right, excluding letter A. I didn't grade A. So if you got the 100, you got those obviously points right, but not everyone did.
Can I take?
Okay, so for G and H, both of them are talking about discuss appropriate controls, and then 4 different things. Like G is saying discuss appropriate controls for one possible confounding variable, and then H is saying discuss appropriate controls for possible experimenter bias. I think this is where people, they didn't they saw confounding variable, they saw experimenter bias, and they went with that. And you didn't answer the question. A lot of people gave me examples of confounding variables. Well, if people had shaky hands, if they had arthritis, if they had this, that, and the other, that would be a confounding variable. And that is how you control for that, is not by not letting those people in the experiment. That would not be very random. If you have a true random selection or random assignment, you're going to get a whole sorts of people. You're not going to just get like, oh, all these people that just happen to not have any confounding variables. Even if they had like high blood pressure that they didn't even know about, that would be a confounding variable. So what do you do to control that, to make sure that those won't mess up the experiment? It's as simple as having a random selection and random assignment. Because then if it's truly random, you'll have people in the experimental group and the control group that will, like, chances are, like, you're going to have arthritis over here and maybe a heart condition over here. Maybe this person's tired over here. Maybe this person has too much caffeine, but they'd be evenly distributed. That way their results would like almost cancel each other out. So on G, having random selection and random assignment is what eliminates confounding variables. Confounding variables will not interrupt your experiment, will not throw off or skew your experiment if you have random selection and random assignment from the population that you're trying to study. And then on H, you have discuss appropriate controls for experimenter bias. A lot of people basically said, well, don't have an experimenter that's biased. Okay. Experimenter bias isn't something that, like, they're trying to do. It's an action that is unconscious, that people are subconsciously changing the experiment by the way that they act. And so you had to say, make it a double-blind procedure. Or a lot of people that got the point right, they just described double-blind without ever saying the word double-blind. They just described it. Like they said, we'll have the experimenter not be in the room, have someone else that represents or the experimenter, and have the experimenter never communicate or have contact with the people in the experiment. And that's what or you could say, they don't know based on the results who was in the audience or who had the audience and who didn't have the audience. So, but the easiest way to say is make sure that the experiment is double blind. And then, of course, to really drive the point home is to then define double blind. And double blind procedure is where neither the experimenter nor the people participating in the experiment know who is the experimental group and who is the control group. So it gets away any experimenter bias. So on G and H, it was how do you get rid of these things, not give me examples of these things. So if you have any questions, I didn't say how I graded it. Basically, if you got nothing right, you got a 50. To get there was a possible 1, 2, 3, 4, 5, 6, 7 possible points. If I remember correctly, it's hold on, let me get the sheet of paper that I graded. Hold on. Okay, so I got my little rubric here. If you got 7 out of 7 points, so you got B through H correct, you got 100. If you got 6 out of 7, 90, 5 out of 7 is an 85, 4 out of 7 is an 80, 3 out of 7 is a 75, 2 out of 7 is a 70, 1 out of 7 is a 60, and nothing out of 7, you get anything right, you got a 50. So the lowest grade I gave was 50, and there, I think was 2 of them, maybe 1 or 2 of them. And then the highest grade, there was several hundreds. 2, maybe 3. So a couple to several. But the majority of people, I think the median score was an 80 or an 85, with the average being around an 80. So don't ask me what the standard deviation is. That's just annoying.